Now we'll see the term frequency. What is the meaning of frequency? Frequency means number of oscillations completed in 1 second. How many number of oscillations are going to complete per second? That is what frequency. And it is denoted by the letter nu. So this symbol is what? Nu. And SI unit of the frequency is hertz, and it can be written as Hz. So if I write 1 hertz means the object will complete one oscillation in 1 second. So the meaning of 1 hertz is the object has to complete one oscillation in 1 second. That means we are going to count the oscillations. We are going to count the number of oscillations in 1 second. That is what frequency. So in the same way, 10 hertz means the object has to complete 10 oscillations in 1 second. Then that is what? 10 hertz. So keep it in mind, frequency means number of oscillations completed per second. That is what frequency. And the relation between frequency and time period is they are related inversely proportional to each other. So that we can write nu equals 1 by t. That means if the time period is greater, then frequency is low. And if the time period is smaller, then the frequency is higher. So frequency and time period both are inversely proportional to each other. Now we'll see in case of periodic motion how the displacement can be represented. So in case of periodic motion, the displacement of the oscillating object that can be represented by a mathematical function of time, and that mathematical function of time is called periodic function. Now we have to understand the meaning of periodic function. Periodic function means any function that repeats its value after a certain interval of time. That means for example, if you consider the trigonometric functions, so you already know that there are 6 trigonometric functions. They are sine, cos, tan, cosec, sec, cot. These are the 6 trigonometric functions. Out of these 6 trigonometric functions, sine and cos, they are called periodic functions. Why they are called periodic functions? So here I will write cosine and sine. These are what? These are periodic functions. So why these two functions are called periodic functions? Because the values of sine and cosine, they will repeat after every 2 pi radians. So once again I will repeat, these two functions are called periodic functions because their value repeat after every 2 pi radians. Okay, now let us prove that one. If I take cos function, so cos 90 value is how much? Cos 90 value is 0. The same way, if I take cos 90 plus 2 pi, I will take cos 90 plus 2 pi. Now I have to find the value of cos 90 plus 2 pi. So cos 90 plus 2 pi means I can write cos of 90 plus 2 times pi means we can write 180. Okay. So now cos, if you simplify this one, you will get 450. Now I need to find the value of cos 450. So I can write 5 into 90 plus 0. 5 into 90 means 450 plus 0. So the 450 can be written as 5 into 90 plus 0. Now here if you observe, 5 is the odd number. So here 90 is with odd multiple number, right? So if there is odd number, then the cos will becomes sine of 0. So the value will becomes 0 only. The final answer is 0. So here the cos 90 value is also 0. Cos 90 plus 25 value, its value is also 0. That means cos, its value is repeating after every 2 pi radians. Cos 90 value is also 0, and cos of 90 plus 25 value is also 0. So the value is repeating, that's why we can call cos function as a periodic function. If you take the sine function also, so its value also repeats after every 2 pi radians. So that's why we will call these two functions are you can call these two functions as periodic functions. So that in case of periodic motion, the displacement can be represented as f of t equals a cos omega t. A cos omega t. Okay. So, and its time period is given by t equals 2 pi by omega. So this means that the oscillating object that repeats its motion after every time period of t equals 2 pi by omega. So this is how we can represent the displacement in case of periodic motion. Now we will see how the displacement of an object can be represented in case of oscillatory motion. So actually in case of oscillatory motion, the displacement of an object can be represented in three different ways. The first way is that you can represent the displacement in terms of cos function, or in terms of sine function, or in terms of combination of both sine and cos function. So the first way, as I said, the displacement can be represented as f of t equals a cos omega t, or we can represent the displacement as f of t equals a. So just now I said cos and sine both are periodic functions. Why they are periodic functions? Because their value will repeat after every 2 pi radians. So that's why we will call them as periodic functions. So these are the three different ways so we can represent the displacement. Now I want to write the equation 3 in the form of single function. So that's why I will take, in place of a I will take d cos pi, in place of b I will take d sin pi. Now if I substitute these values in equation 3, then the equation 3 becomes f of t equals d cos pi into sin omega t plus d sin pi into cos omega t. Now from these two, if I take d common, then d inside the bracket we can write sin omega t into cos pi plus cos omega t into sin pi. Now if you observe this complete term, this is in the form of sin a into cos b plus cos a into sin b, so that the whole term can be written as sin of a plus b. So the displacement of an object can be written as f of t equals d into sin of omega t plus pi. So this is the expression for the displacement in case of oscillatory motion. Now we will discuss the simple harmonic motion. The next concept is simple harmonic motion. So in general we can call that one as SHM. So the motion of an object can be said to be simple harmonic if it satisfies these two conditions. So the first condition is that the restoring force is directly proportional to displacement of object from its main position. This is the first condition. And the second condition is the direction of this restoring force, that is always towards main position. Now let us try to understand the conditions one by one very clearly. So to understand that one, let me draw the simple pendulum. So let us imagine This is a rigid support, and this is a string, and this is a pendulum bob. Now I will apply the small force. I will apply the small force on this pendulum bob. When we apply the small force on this pendulum bob, so the pendulum bob that will goes to one extreme position. Let me say up to this point it has gone. So I will take only a right side extreme position. So I have applied small force. As a result, the object has moved towards this point to the one extreme position, let me say E. So here, after reaching this point, the object will comes back to the same point. Why it is coming to the same point? Because the object has a restoring force. Because of that restoring force, the object will comes to original position. Yes or no? Restoring force means what? The ability of the object to comes back to its original position. That is what restoring force, right? So I have applied the force from left side to right side. The direction of the applied force is from left to right, but the direction of the restoring force is from right to left. Yes or no? So this is for small force. So the first condition is the restoring force is directly proportional to displacement of the object from its mean position. Now I will take another case. I will take another simple pendulum. So this is a pendulum bob. Now initially it is at the mean position. Now I will apply the larger force. If we apply the larger force on this object, then the object will covers larger displacement. Yes or no? So it comes to this extreme position here. So when we apply the small force, the object has covered smaller displacement. When we apply the larger force, the object has covered larger displacement. As a result, there will be greater restoring force. That means the restoring force is directly proportional to displacement. Smaller the displacement, smaller will be the restoring force. Greater the displacement, greater will be the restoring force. So both are restoring force and displacement. Both are directly proportional to each other. So that is what the first condition. The restoring force is directly proportional to displacement of the object from its mean position. And the second condition, if you observe the direction of the restoring force, how it has traveled? The direction of the restoring force, that is towards the mean position. Yes or no? In the first case also towards the mean position. In the second case also that towards the mean position. So that is the second condition. The direction of the restoring force is always towards the mean position. If the moving object, if that satisfies these two conditions, then we can say that object is under simple harmonic motion. Now if you consider an object that is oscillating to and fro about the origin of the x-axis between the limits plus a and minus a. This is the mean position. O is the mean position, plus a and minus a, these are the extreme points. Okay, and if that object is under oscillatory motion, then we can also call that object is under simple harmonic motion, and the displacement of such object is given by x of t equals a cos omega t plus pi. So this is the expression for the displacement of an object which is following the simple harmonic motion. So here x of t is the displacement of the object with respect to time. That means the displacement will changes at different intervals of time, and a is the amplitude of the object, and here omega t plus pi, this is called phase. This complete term omega t plus pi is called phase, and pi is called phase constant. Omega is called angular frequency. So keep it in mind. This is the expression for the displacement of the object in case of simple harmonic motion. So now I will stop and will continue the remaining concepts in the next class.